Alright, so we're going to do a quick demo of the Catalyst 9000 programmability. Let's do a couple verification commands here. So we're going to do show version. We're running 16.81 right here. And we have a 2-node switch stack, both Catalyst 9300s. And it's pretty important to take note of the mode. It's in install mode. The other option is bundle mode. You're going to find that some of the newer features such as SMU, software maintenance update, you're going to have to be in install mode to take advantage of some of those features for high availability, and it won't be able to be executed something like SMU in bundle mode. So we have that. We have a Catalyst 9300, and let's go ahead and take a look at the internal interfaces that we're using to communicate with the Linux bash shell. So I'm going to go ahead and do a show IPINT brief, and I'm going to exclude any unassigned interfaces. And so what we have here is gig00 is my connectivity to my management VRF, show VRF. And then I also have virtual port group 0, which is an internal interface, and something that's pretty important on these boxes when you're doing the guest shell. So here, if I go ahead and ping 192.168.35.2, that's the actual virtual interface of my Linux container that's running the Linux bash and Python. So there we go. I have connectivity. I can do show app hosting, list, and you can see the guest shell is running. I could do show app hosting details, and you can see more information. We're running this Linux container. App ID is guest shell as well as the app name, and it's consuming 256 megabyte of RAM, 1 megabyte of disk space, and 800 units of CPU. That's an internal thing. I think 800 might be the maximum per Linux container, so you can make a you can allocate between 1 and 800. More information is in the documentation on that. And then we have here the IP address that's assigned to the Ethernet 0 interface, which is what we just pinged. So looks like we're all good, right? So let's do show IOX, make sure all services are healthy. Show app hosting, list, we did this already. Just make sure that's good. And I can go ahead and say guest shell run bash. Okay. Now I'm dropped into the home directory of the Linux shell. So let's go ahead and take a look at some of the stuff here. ls, and I can see I have boot flash directory. Boot flash is actually the flash on the CLI. So if you did a dir flash in the iOS XE CLI, it's the same contents here. So I'll do an ls on that, and that's my directory. That's my flash directory. So now you can use cool Linux native stuff, right? Like VI. I don't know how cool that is to you, but I pretty much dig it as an editor. And I'm going to do vi.ka.python, which is a Python script I created. And that's one that I'm going to show you a little bit more in the demo. So, yep, we're good there, and I can quit out of that. And you got all your other Linux commands that are native that you're used to. So we do top. We can get more information, cat proc, CPU info, and we can see that there's an 8-core processor here. The core processor ID starts with 0, so 0 to 7. I have an 8-core processor, Intel Xeon 1526. Frequency is 1.8 gig. So this is the kind of level of detail you're getting from the Linux subsystem that you're not necessarily going to get some of this level of detail through the native iOS XE CLI. If you did a show inventory, show platform, yeah, you might see it, or show version, you'll see it's an x86 processor, but this level of detail, how many cores, what frequency, and all that, you're really able to derive that when you're in the bash shell. So let's do a couple others. So cat proc, let's do memory info. I believe this is an 8 gig. Yeah, 8 gig of RAM. Roughly 5.7 gig available. And what else did we want to do? We want to do a cat proc let's do version, see what version of Linux this is. Linux version 4.4, XE Linux, you know, right there. And I think that's pretty much all that I wanted to show here. One of the key things, the VI, using that to edit a text file, or using it in the case of the Python script, kind of neat because you can create a Python script, put it on box, put it on the boot flash, and then you can edit that Python script directly on the box without having to TFTP or put it on a USB card and go from the USB drive and move it to your PC and move it back to the switch. No, if you need to edit a line of code, you could do it right here on box without ever having to extract and send that file, that Python script, off box for editing. So just a neat little trick. So I'm going to go ahead and exit out of that, and let's take a look at Python. So guest shell run Python. Right, and here, I believe it's 2. Yeah, it's version 2.7 on here. You can upgrade this to run 3, and then you would basically say guest shell run Python 3. So if you're creating a script or a Python program that requires Python 3, no sweat, you can install it on here. But I'm okay with Python 2.7 because what I need to do is going to work. So I'm going to do a help, get in the interactive help. I believe it's like this. Yep, and then I'm going to look at my modules. For this example, I'm just going to use one of these built-in functions, random. So let's go ahead and do from random import rand_int. So that's random integer. And I'm going to print rand integer, a number from 1 to, well, yeah, let's do 1 to 10, right? It's a random number, 1 to 10, 3, 2, 3, right? 1, it's kind of stuck in the low range there. 2, let's go a little bit, yeah, there we go, it's a 7. Let's do 100, right? Now I have a variable, or I have a range of 1 to 100. Boom, 94, so on and so forth. So you get the gist, right? Now I can create Python scripts on box, test them, run them in the interactive, run them interactively directly here on the switch. But what I really want to show is, let's say that we already have some Python scripts, and more importantly, we're trying to augment the functionality of iOS XE, meaning maybe there's some command that you wish existed, but for whatever reason, we at Cisco haven't developed it. So in the case of show CDP, right? We all know show CDP neighbor. And I could see I have core, I'm attached to the core. My local interface is gig 0, I'm attached to the core, which is a 4948, and the remote port is gig 17, right? We know show LLDP if we're in a mixed environment. It's mixed environment, we can do show LLDP neighbor, right? And I don't have any LLDP neighbors on the other side, but what we don't have is we don't really have a command that allows you to show CDP and LLDP neighbors at the same time, meaning I want to run one command, and I want to see all my LLDP neighbors, and I want to see all my CDP neighbors, because I may have a mixed environment that I'm running LLDP, and I'm running CDP as well, and I just want to see them all with a single command. So I had this request from one of the customers, and I created this really simple script. So if I go to more flash Python directory, this is right on the box, and I go to ka.py, this is a Python script that's showing the LLDP neighbors, the CDP neighbors, and it's even showing the dynamic MAC address table. Now this switch doesn't have any devices, end devices connected to the downlinks. I'm only connected to the management interface in this lab switch stack. So I'm not going to really have anything on those ports. I'm not going to have any MAC address show up and populate here. But let me show you what we can do. Of course, we could execute a script directly, right? So I could do guest shell run Python. I'm going to point it to that directory, flash Python. I have another one here called spanning tree, stp.py. This basically is showing me any spanning tree instances. So no matter how many VLANs are out there, show me all the spanning tree instances. Again, I have nothing connected to downlink, so nothing's going to show up. But that's one way you can run a Python script on box. The other way, the more creative way, the more, I think, a lot more useful but more intuitive would be to create an alias. So if I do show run section alias, I created an alias called KA. That's running guest shell. It's executing the Python script ka.py. Now what makes this better is that it feels like a native CLI command, right? I'm not having to remember, oh, I gotta type guest shell run Python. I could give it a friendly name. In this case, I called it KA for killer app. And I just type in KA and hit enter, and boom, it runs the ka.py script, right? And again, this top part's my LDP neighbors, don't have any. The bottom part's the CDP neighbors, and then this would be the dynamic MAC addresses. So that's pretty much what I wanted to show you on this short video of Catalyst 9000 programmability. So thanks for watching.